Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is going over primarily, and we are on year number, so let's go ahead and get started. All right, let us go ahead and get rolling. We are on question number 2005. Now let us begin. On the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. Now, if you remember, slope fields are just an estimation for what the original function will look like. So our goal is, well, simply to just plug the values of these 12 indicated points into my derivative function, and we're going to go ahead and sketch them. Well, remember, our number one thing to do is to always ask ourselves. Also, if you kind of look up above, I kind of got this new cool looking font. It looks kind of cool. You know, it's got a little bit of a stroke with the black on the outside. But anyhow, let us get rolling. We got to plug and find in our zero slopes. Well, if I look at my equation up above, I know that I'm going to get zero slopes when the value is 0. So what do I need to plug into x to get 0? Well, x needs to be 0. I wonder why the color is this over here inside, but then outside it's not. Anyhows, so that means that x equals 0, we should get a slope of 0. So that means here, 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 and here. Now what we're going to do is we're going to think about this strategically. Well, what do we want to do? Well, I personally like to go with the same y values, right? Up here, this is y equals 1. So I want to plug y equals 1 into my function, and then we're going to basically plug in the x values that corresponds with that. So for example, this is 1 comma 1, right? So if I plug it in, I'm going to basically get negative 2x over 1 at this value because the y value is 1. So if I plug in 1, negative 2 times 1 is negative 2, divided by 1 is negative 2. So that tells me this is going to be a slope of negative 2. If I go to do the same thing to this other side, I'm going to get negative 2 divided by negative 1 divided by 1, which is going to turn into a positive 2. So now my slope field is going to look like this. It's going to be positive. I drew that one a little darker than the other ones, but that's okay. Or maybe I can fix it. No, it's okay. And now we're going to do the same thing with y equals 2, y equals negative 1, and y equals negative 2. Again, I want to go about these in a strategic manner. I don't want to just go down this row where all the y values change. I want to stay in the row where the y values stay the same. So if I plug in 2, I'm going to get negative 2x over 2, which is essentially negative x. So now if I plug in my values into here, right, if I plug in 1, I get negative 1. So now my slope is, it's not as steep as this one here, right? So maybe something like this. And then if I plug in negative 1 into here, this becomes a positive 1. So same idea, just a little bit more horizontal, not necessarily as steep. And then we're going to do the same thing on the bottom here. So I'm going to go ahead and do that. So let's go ahead and do that to these points as well, and then you can go ahead and get these filled in. So I'm going to stop here. I'm going to let you do the rest of these points, and we're going to move on to part B. Again, if you do have a question, just let me know. I kind of just want to go over and get you started and then go over the questions that I think are most difficult. Let's go to part B. Let y equals f of x be the particular solution to the differential equation with initial condition f of 1 equals negative 1. Okay. Write an equation for the line tangent and use it to approximate f of 1.1. Well, I've kind of skipped this question in the previous videos, so why not? Let's just go through part B because it's one that I've skipped. So let's go ahead and do that together. So we already know this is what we're going to do when it's asking for the equation of the line tangent. Okay, so I rewrote it for you just to kind of get us rolling, to kind of streamline this process. When it asks for the equation of the line tangent, that means we're going to get this function right here. Now, because of this, that's basically telling us that we need to figure out what is the equation line tangent to this function, right? Essentially, if you got some graph, we're trying to find this equation right there at this exact point. Well, it gave us the point. The x value is 1. Let me put an x right here, and the y value is negative 1. So I plug in the 1 for the x. That's why it's x minus 1. And then I'm going to plug in the negative 1 here. Well, this is going to be y minus negative 1. So that's going to turn to a positive 1. So that's why I got this bottom row filled out right here. And then how do we find m? Usually to find m, we got to take the derivative of our function and then plug in our values. Well, here's the good news. They actually give us the derivative right up above here. So we don't even need to take the derivative. We're already given it. So let's go ahead and write it out. So I rewrote dy dx is equal to, well, negative 2. I'm going to replace the x with the y with the x value, which was 1, and then the y value is underneath. Well, what is the y value? Well, the y value is -1. So I'm gonna write that out down here. We get -2 over -1, and we get a +2. So now I'm gonna go down here and rewrite this one more time. Y plus 1 is equal to 2, and then we get x minus 1 right here. So now what do? Well, we finished part 1, but it says use it to approximate f of 1.1. All that really means is we need to take this 1.1 now and plug it into the x to approximate that value. Essentially, if I was to zoom in, let me go ahead and draw this graph, and I was to write an equation of the line tangent, let's say like right here. Let's say that at this exact point it's x equals 1. Well, we're basically taking this line tangent, we're going to plug in 1.1, so maybe this point right here, and we're going to approximate the value of our function. Notice how they're super close to each other right here. Do you see how they're super close? That's going to give us an approximation for what the y value would be of the original. So this approximation is just going to help us know, hey, what is an approximate value of our function? I know it's not the exact value because it's this line tangent that we're actually getting, but it's going to give us some approximate value compared to this value right there, which should be really close. So that's what essentially we're doing here. So let's plug in the 1.1 into here. 1.1 minus 1 is 0.1, so we're going to get y plus 1 is equal to 2, and then we get 0.1. 2 times 0.1 is 0.2, so we get y plus 1 is equal to 0.2. We're going to subtract the 1 to both sides, and we get y is equal to -0.8. Hopefully I didn't do any math wrong here. And then finally, because it asks us to approximate f of 1.1, I'm going to just go ahead and write f of 1.1 is equal to -0.8. And there is my value for part B. I did the two parts. I wrote the equation of the line tangent here, right here. And we figured out what is f of 1.1, which is right here. Again, I'm boxing them. You never want to box anything on the AP exam. And then we got the slow fields. Awesome. Let's go ahead and go on to part C. Okay. Now we shall begin part C, which is find the particular solution y equals f of x to the given differential equation with initial condition f of 1 equals -1. Now, it's asking for y equals f of x. That should always be our hint that it's asking us to go back to our original function. Because of that, we need to separate the variables and do what we've done in the past. So let's go ahead and do it. We're going to multiply dx to both sides. Boom, just usually pretty standard. The y is on the denominator, so I'm going to multiply y to both sides. Shazam, like this. And then we should get y dy is equal to -2x dx like such. And then now that these values are separated, we can take the antiderivative of both sides, which I'm going to do a little bit more quicker because I think this one's going to be a very nice one to do relative to the ones that we did prior. So we get y squared over 2 is equal to -2x squared plus c. And then now that we have this function, we're going to plug in our initial condition. The 1 goes into the x, the -1 goes into the y. So we're going to get -1 squared over 2 is equal to -2. I'm going to try to go through this a little bit faster. 1 squared plus c. Let me go ahead and bring it right up here. So what we're going to get now is 1/2 equal to -2 plus c. -1 squared, -1 times -1 is 1. 1 divided by 2, that's the 1/2. This is -2 plus c. We can go ahead and add 2 to both sides now. Shazam, shazam, like this. And we get that c is equal to 2.5. Boom, right? I'll just leave it as a fraction because it's 2 plus 1/2, that's 2.5. So we're going to take the c value that we just kind of discovered here, and we're going to plug it in to here. So now we're going to get right over here is y squared over 2 is equal to -2x squared plus c. And then once, not plus c, my apologies, plus 2.5. And then now we just need to solve this out. Well, to solve this out, we're going to basically solve for y. Take multiply 2 to both sides. So we're going to put parentheses, put a 2. These are going to cancel. We get y squared is equal to, this is -4x squared plus 2 times 2.5 is 5. And now we take the square root of both sides. Don't forget plus or minus, so we get y is equal to, well, where's our initial condition? Where our initial condition is 1 comma negative, sorry, I don't know why I wrote it twice. That means the point is down here. That means our square root function lives down in the x and y plane down below here. So if I gotta choose one of these to keep, I'm gonna keep the negative square root. So negative square root, negative 4x squared plus 5. And there it is. I have completed this problem. Hopefully that makes sense. And hopefully as you're going through all these years, they're all kind of coming together. Well, with that being said, y'all, I'm out. Take care. Capiche?